Hello everyone, we are starting Aldol and Cannizaro reaction from MSc Elementary, and this is the part of Aldehydes and Ketones chapter. We are doing from question number 1 to question number 10 again. Now starting from the question number 1, we have been given a compound which is an aldehyde and we are expected to do the aldol, and here the heat given is 5 degrees Celsius. Basically no heat is given, hence the product will not be alpha beta unsaturated carbonyl compound. This is first thing which you should understand when you look at the question. Okay, so they have asked what is the product form. Let's understand through the mechanism. So here you have this is your aldehyde group, this is your alpha carbon, there is a OH minus here. From alpha carbon it will remove the hydrogen because this CO group, carbonyl group, is electron withdrawing, hence the alpha carbon's hydrogen become acidic by nature. This is removed and you get a carboanion and the water is released. After that, this carbanion attacks on the carbonyl group which has a delta positive charge. So this attacks from here to here. So attack is happening from carbanion to the carbonyl carbon. This is your simple nucleophilic addition reaction. Now we will mark the numbers so that it will be easier for us to track how to join the compound. Let's mark this carbon as carbon 1, 2, and again this carbon as carbon 1, 2 and 3, 1, 2 and 3. So carbon number 2, this is your 1, 2 and 3. Second carbon is getting connected to the first carbon, that is carbonyl carbon of your molecule. So carbon number 2 of one compound is one species is connecting to the carbon 1 of the another species. So this is how the chain is connected. Now because the water has been generated, the H will be given to the O minus and the alcohol will be formed. If you see, this is your option number A. Now come to question number 2. In question number 2, we have been given a ketone and there is a medium given as HCl with water. That means they are expecting us to do the acid catalyzed aldol. Now acid catalyzed aldol, I will explain the mechanism using this example itself. Many people may not know the acid catalyzed aldol because in NCERT it is not given. But it is as important as the base catalyzed aldol. So let's begin with it. So we have this ketone given. This is my alpha carbon with the alpha hydrogens present on it, and this is my carbonyl position where you have a delta positive and delta negative charges separated. Now because the medium is acidic, the H plus will go and attack on the oxygen of carbonyl carbon first, forming OH plus. At the same time, because this S plus is generating from HCl, there is a dissociation of H plus and Cl minus. Cl minus will act as a conjugate base and will attack on the alpha carbon's hydrogen and will take it out. These hydrogens are relatively acidic in nature because it has a minus M group present next to it. So chlorine will take away the hydrogen. At the same time, oxygen has made the bond with hydrogen and has become protonated. Now in this process, you see oxygen carrying a positive charge will try to break the bond with the carbon to neutralize its charge. So that means what we assume is there will be a positive charge development over here and there will be a negative charge development on this carbon because the hydrogen is going out. So both of them will form a double bond. So that means the molecule will look like this. You will have a OH now and there is a double bond between the carbon of carbonyl and the alpha carbon which was earlier an alpha carbon. So it becomes this. Now at the same time, another molecule of aldol would also have become protonated and Cl minus would be in process to remove the hydrogen from the alpha carbon. But even before that, my alkene will go and attack onto this carbonyl carbon. Alkenes are electron rich and carbonyl carbon is electron deficient. So this electron density will shift like this because we know that the positive charge is more stable on this carbon. This carbon will attack on the carbonyl carbon. Let's mark this carbon as carbon 1, carbon 2 and carbon 3. Mark this also carbon 1, 2 and 3. So carbon 1 in the compound in this species will attack onto the carbon 2 which is carbonyl carbon of the another protonated aldehyde. So how will it look like? It will look like this. This is my carbon 1, 2 and 3 and this is my carbon 1, 2 and 3. So my carbon number 1 has attacked on carbon number 2 which was the carbonyl carbon earlier and forming a carbocation on the second carbon which is a intermediate state and which will immediately get neutralized by the lone pair given by the oxygen. So the lone pair will be given by O here, forming double bond OH like this, and this H plus will be removed to get the carbonyl group. So you will get a C double bond O over here, CH2, COH, and H plus is out. Cl minus was already present, so they will combine and will form HCl. Now again, understand this medium is still acidic and the reaction will just not stop here. because my H plus can further go and attack onto the OH and form OH2 plus. At the same time, Cl minus can act as a base and remove the hydrogen from the your active methylene group. So this will act as an active methylene group. Hydrogens are acidic. Cl minus will be nicely be able to take it. Here you will develop a positive charge. Here you will develop a negative charge, and eventually a pi bond will be formed. So what you can see here is that even without using heat, what we are getting is alpha beta unsaturated carbonyl compound. Carbonyl compound. And this is in the case of acidic aldol. In base aldol, we require heat. Here, we do not even require heat. So the product will be your alpha beta unsaturated carbonyl compound, same as base catalyzed. Only the mechanism is different. Product is same. Now come to question number 3. In question number 3, they are asking which is the starting material used in the following reaction. Now here what you have given is beta hydroxyketone. Now understand, in such reactions we can directly use the trick. What is the trick? Form the alpha beta unsaturated compound out of the molecule given. That you can do by simply heating this. So this is the compound given. We are heating and forming the alpha beta unsaturated carbonyl compound. So there will be a double bond formation here. Okay. Once the double bond formation is done, mark the alpha and beta carbon and cleave it in your mind from here, and add H2O in such a way that 2 hydrogens you are adding, not like, this is not a mechanism, this is a trick. So add 2 hydrogens on the alpha position and 1 oxygen on the beta position, and you will get the molecule. So when you cleave that, you will get benzene COCH3 from the first part, and from the other cleaved part you'll get COCH3 and benzene, which is the same molecule. Both of these molecules are same, and this is your option number D. So this is just a trick. Now come to question number 4. In question number 4, they are asking which of the following compounds is the product of an aldol condensation reaction. Always remember, aldol condensation produces beta hydroxycarbonyl compound or alpha beta unsaturated carbonyl compound. So we just have to find where this beta hydroxycarbonyl compound is present. We don't have to do actually the whole reaction or something. So if you see the compound C has, this is your C double bond O, that is ketonic group, then alpha position, and beta position pe OH is present, which is not the case in any of the other given compounds. Hence the option is C. Now come to question number 5. In question number 5, we have been asked to form the product of the given reaction, where you have to do the aldol. In one, we have taken benzaldehyde, where there is no alpha hydrogens, whereas the other is cyclopentanone, which has the alpha hydrogens. So the reaction will begin from cyclopentanone. In cyclopentanone, the base will attack and will remove the hydrogen from the alpha position, forming the carboanion. That carbanion will attack on the carbonyl carbon of the benzaldehyde, and when that will happen, this is how your molecule will look like. This CO minus H and pH. Now we are adding water so that this O minus become OH. Adding water means the water is there in the system, in the solution, which is formed by the base and the hydrogen, and that is basically protonating this oxygen, which has a negative charge. So it has become OH. Now because the temperature is given 100 degrees Celsius, there is gonna be an elimination. So OH from here and hydrogen from this position will be removed, and this alkene, that is alpha beta unsaturated carbonyl compound, will be formed, which is your molecule C. So answer of this reaction is C. Now come to question number 6. In the question number 6, we have been asked the product of the reaction. NaOH and heat is given. 2 ketones are there. Clearly it looks like it is an intramolecular aldol. Now let's see how to do the reaction. So we have a NaOH, which will take out the alpha hydrogen. So this is your alpha carbon over here. Though we have a alpha carbon here and alpha carbon here and alpha carbon here also. If you consider all the possibilities, if you try to take hydrogen from here and attack here, then it will be too small of a chain. 1, 2. So it will be 1, 2, 3, 4 and 5. There will be 5 carbons, and it will be something like this. And this will be attacking here, forming something like this. 1, 1, 2, 3, 4. 4-membered chain. 4, 1, 2, 3, 4. I'll just draw it a little bit. So it will be something like this. And they will be, this is carbon 1, then carbon 2, carbon 3, and this is your carbon 4, and with the CH3. Something like this will be formed. Now let's see the products given. None of this compound is given, so they are not expecting a bicyclo type of compound. Sorry, spiro type of compound. They're expecting a bicyclo compound. So basically, in that case, they are assuming that the hydrogen will not go from here. Instead, it will go from the other side, from the open chain. Okay. Now, if I'll attack from this alpha, then the chain will be 1, 2, 3, 4, 5, 6, and 7. 7-member chain will be there, which is way bigger than the normal stable size. If I take out the hydrogen from this position, this is carbon number 1, 2, 3, and 4, and 5. 5-membered ring will be formed, which is a stable ring. Okay, so clearly we will be forming a 5-membered ring instead of a 7-membered ring. And now let's begin. Okay, one more thing. So I was telling you that if I'll remove the hydrogen from here, this kind of chain will form. Instead, thinking it in that manner, we can also say that we require minimum of 2 alpha hydrogens for the reaction to take place. If we have only 1 alpha hydrogen, that means that particular carbon is too crowded and base will not be able to remove the hydrogen from there. Let's suppose if base removes the hydrogen from there to form a carbonyl, which will be a 3-degree carbonyl, which is very difficult to form at all. If it forms, the carbonyl carbon attack will not be possible because that nucleophile will be very sterically hindered. So that way you cannot actually start attacking from this position at all. I mean this position at all. This position cannot be used. Okay. So we need 2 alpha hydrogens, not only 1. That means we can maximum afford a 2-degree carbon. We definitely cannot afford a 3-degree carbonyl to be formed after the reaction is happening or after the base is attacking. Okay. So here, this, it will attack on this carbon. This will break the bond. So this is how my species will look like. If I'll shape it properly, then in that case, it will look like this, what I have drawn over here. And after this, it will take the water's hydrogen, OH will be formed, you are heating, and alkene will be formed. So OH will be removed from here and hydrogen from here. A conjugated system will be formed. So this option is option number D. So even though in my molecule we had 3 alpha positions, one, I'll just show you. One position this, one position is this, and one position is this, from where we could, not this, I mean this, from where we could remove hydrogen, but still we'll be choosing only one on the 2 bases. One is that one is quite sterically hindered, carbonyl it is forming, and in the other case you are getting a bigger cycle, 7-membered cyclic ring, which is not we prefer to form whenever we are doing the intramolecular aldol or any cyclization type of reaction. Now come to question number 7. The question is, which of the following is not the product of intramolecular aldol condensation? Here I'll be using complete trick. There have been all the options given. I will just take alpha beta bond, alpha beta double bond, and I'll be breaking it and we'll be checking what is the compound forming, whether it is a intramolecular type aldol or not. So I have taken alpha beta over here, 2 hydrogens I have added here, oxygen I have added here. I have taught this trick in the previous questions. So it will become like this. So it is clearly an intra aldol type of molecule, where if you'll do the reaction aldol on this compound, it will give you this product. Now here, if you break it, again there are 2 hydrogens here and oxygen here will be there. So this is again one ketone, one aldehyde on the same molecule. It will be forming the compound using intraaldol. Now let's break this bond. I'll be placing 2 hydrogens there and oxygen here. In that case, it is cleaving into 2 different compounds. So definitely it's not intraaldol. And 4, in 4 you'll cleave it here, you'll get a double bond over here and you'll get a H2 over here. So this is what the molecule you will get, initial molecule, and this is also an intraaldol product what we have formed over here. So the option according to this should be option number C. All other 3 are the intraaldol products. Now come to question number 8, in which they are asking which products should be formed in the following reaction. So in this reaction, again this is an intramolecular aldol. Let's see how it is happening. So I have this compound given. I have taken NaOH and H2O, NaH and NaOH and H2O. Alpha hydrogen has to be removed. I have what all alpha positions? This alpha, and this alpha. Okay. If I remove from alpha 1, then it will form 1, 2, 3, 4, 5-membered ring. If I remove from alpha 2, then 1, 2, 3-membered ring, which is quite unstable. If I take from alpha 3, 1, 2, 3, 4, 5, again 5-membered carbon chain will be formed. So you can take the hydrogen out by base from alpha 1 or alpha 3, both will be right and both will give you the same product, okay, because it is a symmetric chain. So negative charge will develop over here, hydrogen is removed from here by the base attack, and this carbon will attack here, and it will form the molecule like this with the supply of water, and this will give away the water molecule and form alkene like this, which is your option number D. Now come to question number 9. Again, this is an intramolecular aldol reaction. They are asking you the major product. In this, we have a one aldehyde, one ketone. Always remember this thing whenever we have an aldehyde and ketone reaction happening. The hydrogen will always be removed from the ketone side. Reason being that later on in the second step, nucleophilic addition reaction is going to happen, which is faster in case of aldehydes as compared to ketones. Hence, the nucleophilic attack happens on aldehydes always, and the removal of the acidic hydrogen happens from the ketone. Okay, so we have this position and this position that way. This is alpha 1, this is alpha 2. But we'll prefer from the alpha 2 because it is going to form 1, 2, 3, 4, 5, 6, 6-membered ring after the intra-aldol. So we will remove the hydrogen from here, causing this carbonyl to form. Then attack will happen this, and then you will supply the water. So this kind of structure will be formed. And when you will remove, so basically this is attacked over here. If you can understand what has happened, it would have formed 1, 2, 3, 4, 5 and 6-membered ring. This is your first carbon, this is your sixth carbon, and then O minus would have formed, which would have taken the H from H2O, forming OH. Now base and heat, so basically elimination will take place, so double bond will form over here. Okay, this. Now in the book, I think the answer is given C, which is wrong. I think answer should be B. If you think there is a mistake in my solving, you can just let me know, but I think answer should be B. Come to question number 10. In question number 10, it is very simple aldol condensation of the same molecule. This is the molecule given, carbonyl formed by the base. This will attack onto this carbon. Carbon-oxygen bond will break. Then there is H2O, which will supply the H to this oxygen. So this kind of beta hydroxy ketone will be formed. When you'll heat it, this OH from here and hydrogen here will be removed from here, forming alpha beta carbonyl compound. This hydrogen is gone by OH minus, forming H2O. I hope you have understood. Now I'm not taking much time in explaining the answers because we are repeating the working of aldol.